So today for this session, we have Cameron Laidlaw. He's the team lead with technical services with Passive House Canada. He's going to be providing a session on the Windows certification for Passive House products. Windows are a critical component of achieving Passive House performance for both new and existing buildings. This session is going to provide attendees with a background on the Passive House, as well as a detailed dive into the details and requirements of Passive House window design and certification for Canadian context. Thanks. Cameron?
All right. Yeah, you can all hear me all right? Yeah. Okay, perfect. Yeah, so we can go ahead and put the slideshow up. Okay, and we'll just make sure this is working. Okay. Try again. Okay. There we go. Okay, maybe just a bit of a delay. Yeah, so thank you very much for the intro. Oh, okay, we're going backwards.
Hang on, why does it do that?
Am I going the wrong way?
Try again.
Try the other one.
Yep.
Okay, it's this way. Okay, all right, that's on me. Okay, sorry, everybody. Yes, so I'm Cameron Laidlaw with Passive House Canada. Here to talk about Passive House and Passive House window certification. A little bit about my background. Previous to joining Passive House Canada, I was a Passive House certifier and designer working on projects across Canada and across the world. Everything from single family to institutional to high-rise retrofits, all kinds of projects types. And, you know, for every one of those, windows are a critical component. So that's what we're going to focus on today. I will just, you know, for those who might not be familiar with us, Passive House Canada, who we are, we're a national nonprofit professional association who advocates for the Passive House standard. We offer advocacy, education events, as well as consultancy in, you know, really anything to do with Passive House. We're there. So just a little bit of background. We don't have a ton of time, so we're going to go quickly through the sort of Passive House basics portion. But you know, this kind of knowledge, I think, is important to have or to set the stage as to sort of what we're doing, where we're going. So you know, we all understand that our buildings are a huge part of our carbon footprint, a part of our energy footprint. You know, depending on what metric you're looking at, the numbers will vary. But in every case, however you look at it, buildings play a huge part and make up a huge part of the pie. So what are we talking about in Canada in specific? It depends on the type of building you're looking at, but you know, you can see the sort of, I hope it's legible to the people in the back, but the sort of gray bar and the like darker black bar are residential and non-residential buildings across Canada. Those represent average energy use figures. For the existing building stock. That's not necessarily every new building that's built, but that's where we're at in terms of if we take an average across the whole country. When we talk about Passive House, what we're talking about is shrinking those bars. And in specific, we're talking about space heating. This is the dominant energy use that we see, you know, on average on buildings across the country. Again, it'll depend on your location and your building type, but at a high level, you know, space heating is where we see the biggest amount of energy currently spent and the biggest potential impact, right? There's some stuff we can do in terms of improving the efficiency of our water heating, of our appliances and whatnot. But if we really want to crush down our demand, shrink the amount of energy we're using on the whole, space heating is where we can really make a big difference. And as a result, that's where we focus for Passive House. We're focusing on that space heating, on bringing those bars down. And kind of building off of the sort of shrinking demand piece, a new part of the energy use discussion these days is sort of this term net zero, not 100% perfectly defined. Different people use it in different contexts. People talk about energy, people talk about carbon, but really no matter how you're talking about it, if your intent is to get to zero, however you want to define that, whether you want to allow people to generate on or force people to generate on site or buy renewable energy credits, separate discussion. But if the goal is to get to zero, again, the easiest way is to bring your demand down. You know, we could technically make any building we want net zero by adding enough solar panels to it. We just generate as much as we use. We can blow as much energy out the door as we want. But if we bring down the size of those bars, that 15 that we saw in the last slide, it's a lot easier to hit that zero, right? We don't need as many solar panels. We don't need to build, you know, as many wind turbines or whatever renewable solution you want to use.
That was me. Sorry.
all right.
Sorry.
Okay, back to it. So if our goal is to get to zero, passive house is an excellent path to get there, right? It doesn't by itself require us to be at net zero energy, but if that's somewhere we want to go, passive house will get you there a lot easier than starting from, let's say, a regular building. If we were doing a full passive house intro course here, we'd go one by one through all of these principles here. But, you know, seeing as this is a window and door conference, the one we're going to focus on today is this one here, windows. All of these are important. And when we combine them all together, they all add up to delivering us those outcomes that we were talking about of crushing the demand, shrinking the amount of energy we're using down from our, you know, typical building energy use down to that, the 15 for space heating and the lower values for everything else as well. And Windows is a huge component of that. So just a little bit of context about the types of projects. You know, one of the things that people hear when they hear passive house is they hear the word house in it. It's sort of, you know, is a bit of a misnomer, I guess, or it leads people to think it is one thing when it is not necessarily just the one thing. You can do a passive house single family build. Absolutely. There's a ton of them across Canada, but it's not only that. There's high-rise tower retrofits at the bottom right there, Riverside Drive East. We've got, you know, brand new affordable housing top left in Fort St. John, another tower retrofit in Hamilton, Ontario. These are just some multi-unit residential projects as well as institutional projects. We're seeing a lot of interest from institutions like universities, for example, Humber College in Toronto, Humber NX, or the bottom left, Clayton Heights Community Center out in Surrey, BC. These are all passive houses. You know, they're not the sort of typical image that some people get in their head of just a boring gray box with no windows. Obviously, you know, you can have your architectural design features and still meet your performance requirements. So diving a little bit into the windows specifically. So at a high level, these are the requirements we're trying to hit. Passive house for Windows, or the certification scheme for Windows, is based on this climate zone approach. So within each of those climate bands, and you can see the map at the top left there that gives you a rough idea of where the bands fall more or less. It's not 100% accurate because, you know, elevation changes and proximity to water can influence things some, but roughly speaking, that's where the climate zones are. Within each of those bands, we have a set of requirements, the same set of requirements for each climate zone, but the stringency or the difficulty of hitting those requirements, they're sort of ratcheted up as we get into the more challenging climate zones. In Canada, these are the two that, you know, the vast majority of the populated area of Canada fall into. The cool temperate, so that'd be like Toronto, Vancouver, you know, a lot of the GTA. As soon as you move outside of the GTA to Barrie, London, up into Montreal, you know, Alberta and those kind of places, it's by and large cold. And then, of course, you know, when you go up to Northwest Territories, things like that, we fall into the Arctic. We'll discuss kind of each of these metrics a little bit more as we go, but you can see we've got a component U value, which is, you know, the overall performance of a window. So that's the glazing and the frame combined with a set size. That's the value that we need to meet. So 0.8, 0.6, 0.4, as well as a hygiene criterion. And again, we'll talk about this some more, but this is basically a metric that is assessing, do we have the potential for mold growth? Mold growth is not instant, but if we take a look at these windows over time, is there the potential for water activity or moisture accumulation over a long enough period that we could have risk of mold growth? And there we go. And just a little note on the climate zones. It's a bit of an information dump here, but just because I know not everybody thinks in passive house climate zones like I do, you can see a bit of a reference there into NECB or how NECB classifies climate zones instead. So you can see it's not a straight one-to-one where the boundaries fall. PHI kind of, the Passive House Institute kind of draws their lines of climate zones a little bit differently than we do, but roughly speaking, you know, there's some figures to sort of situate you if your mind works in that way. And just a note on some of the modeling standards. Some people, if there are modelers in the audience, I think there might be a few. Some people like to see, some of these standards here. That's what we're going to use to, oh, okay, this is the slide that got messed up. There we go. To determine these values here. So the certification of Windows, this is one certificate on the right here. Certification for a window is going to follow or contain assessment of those three values that we can see, which relate us back to the chart that we saw with the map earlier. The primary one is that comfort one. So we saw the comfort requirement, the U value requirement at the top. You can see, again, the text is a little bit small maybe, but the UW installed, so both the window on its own and then the window as it's actually put into the wall. This is something that differs from some other assessment schemes in that we can take a really great window, and if we put it in a wall and we don't really consider how we're doing that and think about thermal bridging through that install, we can kind of take a good product and sort of waste some of its potential by not installing it in the best way we can. So part of the certification scheme for Passivhaus windows is to not only model the window on its own, also model at least 3 different verified installs. Hygiene criteria, again, which we talked about, and then airtightness as well. Again, and I'll break those down as we go. A little bit of the theory behind the numbers that we're looking at. We've been talking a lot about numbers so far, but really, we know that buildings are for people, right? And these numbers weren't just picked out of the air. These numbers were picked to deliver comfort, to deliver, satisfactory indoor spaces or really exceptional indoor spaces for the occupants. So we know that with, let's say, a typical window, I've got an example up there of 1.6, U value of 1.6. In these design conditions, we're just making some assumptions here about if it's -14 outside, we end up with a really high degree of temperature asymmetry between our interior, operative temperature or interior surface temperatures of like our interior wall and the feeling of cold that is radiating off or that you're radiating to that cold window. You're going to sit by the window. Everybody's felt this. You go to a restaurant and you sit by the window and you feel really cold, right? The surface of that window is really cold. It's not a comfortable space to be in. In this example, we've got a radiant temperature asymmetry of 5.5 degrees. That's enough that you can feel it. You're not going to be comfortable. You need some kind of compensating heat source near that window to maintain comfort. Usually, it's a radiator of some kind or warm blown air that's pushed towards that window to really make up for the fact that it doesn't have the performance to keep you comfortable by default. If we then look at let's say, Passivhaus certified window of, in this case, that 0.8 U value, which is appropriate for a cool temperate climate, the temperature, of course, of the window is not going to be the same as the interior surface temperatures, let's say on the interior wall, but it's going to be a lot closer. The difference between the two is going to be a lot lower. And when we're talking about this, roughly 3 degree Kelvin or degrees Celsius temperature difference, that's a level at which you're not going to notice it in the same way. You're not going to sit there and feel, I'm uncomfortable. I need to keep my coat on sitting at dinner or whatever it is. So with this kind of thinking in mind, where this is sort of the end goal we're trying to get towards, the numbers that we saw in the previous chart were chosen to say, we know that within these temperature zones, if we specify components at these specific performance levels, we're going to achieve these outcomes, right? We're going to achieve these higher surface temperatures. We're going to have people comfortable. We're not going to need to put the heating system right next to the wall. We're not here to talk about heating and cooling systems today, but the sort of knock-on effect is it changes how we need to specify or to install our heating and cooling. We don't need to necessarily run perimeter heating around the entire building, for example, or put a grill at each window, like a lot of times you have to do in standard construction. And just to bring it back again, because I'm throwing a lot of data and numbers out there, I wanted to put these numbers back up again. So the numbers that we saw before, these are the same ones, just pulled out of the table and put against those climate zones that we have in Canada. Okay, so some details about how we are actually calculating those numbers that I just showed on the last slide. So we've got the 0.85, 0.65, and 0.45 for the different climate zones in Canada. It's a big, long calculation, and it looks very intimidating, but it's pretty straightforward when you break it down element by element. So the first one is the U value of the glazing times the area of the glazing. We also add in the psi value of the spacer separating the panes of glass. In this image, this is a double pane window. In Canada, if you're going for Passive House, pretty hard to get away with double pane. I don't know that I've personally seen a Passive House project here in Canada that did double pane. There might be one, but usually it's triple glazed. But in either case, we're adding the psi value of the spacer times the length of that spacer around the perimeter of the window. We've got the performance of the frame itself. So the U value of the frame times the area of the frame. And then we've got the psi install value, right? So this is the piece that we were talking about. The install, if we've got a really, really great window, but we don't install it very smartly, we can have a lot of thermal flanking, a lot of thermal bridging. It just, it kind of negates the value of a good window in the first place. And to, what do we sort of need to take away from, that equation is a lot of theory, a lot of numbers and math, but what does it take to actually get us there? So you can see the really important parts of the equation are: one, a good spacer, right? This is a spot where traditionally we lose a lot of heat. It's almost always the coldest spot on the frame. So any improvement we can do at this spacer, it runs the entire perimeter of each pane of glass. So it has a really, really big impact. That's number one. Number two is a slim frame. This is not mandatory, but when we're calculating out the overall performance of any window, the glazing is going to perform better than the frame. So if we can maximize our glazing area, I mean, we've got potential for more solar gain, which in a lot of cases, in most cases in Canada is good. Not always, we need to be mindful, but we've got, better views to the outside. We've got more potential for solar gain, and we've minimized the area of the relatively poor performing element, which is the frame. And whatever frame we do have, we want to make sure it's well insulated. This example is a wood frame, the sort of lighter yellow, and the orange is insulation. Not every frame is going to look exactly like this with that continuous exterior insulation. You see this mostly on wood frames, but whatever type of material you're using, you're going to want to make sure that it is fully insulated. Just want to do a time check. Okay. And then just a quick note about curtain walls. Obviously, there are more elements to consider with curtain walls: glass carriers, screws, things like that. Those didn't appear in the equation that I showed before, but if we're talking about curtain walls, these elements are going to be added into the equation as well. They're going to be accounted for, in addition to everything else we've already talked about. And here we go. Here's some of the examples. Some manufacturers that I talk to, they think, oh, okay, I saw the wood frame, it can only be wood. Not so. We've got 4 examples here of different. These are all certified Passive House frames, and the 4 typical frame materials that we see. The strategies are all very different, as you can tell, but it is possible with any of these to reach the levels of performance that we're talking about for Passive House. Okay, so a little bit of detail. Let me. Oh, okay. Our controller's having a bit of issues. Apologies. So we talked about the overall U value. We talked about the, what we call kind of the comfort requirement. In addition, we've got this requirement, the hygiene piece. So what we're concerned about here is ensuring that over an extended period of time, we don't have surface temperatures low enough that we're concerned about condensation forming and allowing ideal conditions for mold growth. We know that mold growth isn't instant. So if you look, I think, yes, it's at the bottom just below the chart. It says average minimum temperature over several days, right? We know that mold growth won't happen in an hour or instantaneously or whatever. So we take a look at the average exterior temperature in different locations across the country, and we see where do they fall, what sort of performance do we need to get, or do we need to obtain in these different locations to ensure that over the coldest average temperatures, we don't sustain the conditions for mold growth over that period. That's maybe a bit of a wordy way of saying it, but essentially this is assessed both at the project level and at the component level. So I know that most of the folks here are in the window industry. So I wanted to put this up just to show that there's sort of a difference between the component the component certification and the project certification. A project needs to adhere to its climate specific location, its location specific data, whereas let's go to the next slide, maybe make it more clear. The window frame certification, the component certification, has to adhere to those climate bands that we saw before. So it's when people are talking about passive house projects, they will talk about passive house projects. How do I say it? There's every passive house project has its own building specific energy model built. And that energy model that is built is based on situates the building in its exact location in the world. For components, we know that they're specified across multiple projects. And so any assessment that's done on the specific project level isn't necessarily going to capture what might happen, say, between Toronto and Vancouver. Technically are both in the same climate zone, but obviously have very different design conditions. So the important takeaway for manufacturers is that we've got sort of these breakpoints based on the climate zones, as opposed to saying we're certifying our component for Montreal or for Toronto or for Vancouver. It's for an entire band, an entire zone that's going to be made up of multiple, or is going to contain multiple cities, perhaps.
Oh, you've got to go upstairs to 210.
Okay, we also had a piece on airtightness. I'd be interested to hear perhaps during the Q&A. This is not my area of expertise, this airtightness part. I'm more on the modeling side and the comfort side. So I'd be interested to hear if anybody does have any expertise in this. But to my knowledge, the airtightness standards in the EU and North America, I'm not aware of any direct comparison or way to convert them. Passive House was originally a European standard, so their documents tend to refer back to the EN standards, the European standards. But the important takeaway for airtightness is that what we see with, I would say, pretty much every passive house window frame is they're going to be triple gasketed. This serves two purposes. One is airtightness. It gives us an additional sort of belt and suspenders, or gives us a belt and suspenders approach to our airtightness. We've got another seal there, sort of a backup. It also splits up the air cavity in these operable frames, which from a thermal perspective gives us a pretty big boost because it shrinks each of those air cavities. There's less possibility of convection within the cavities. And we see the performance actually go up on the comfort side as well. Taking it back to the project side, which I talked about a bit earlier, every single passive house project that is built is going to have a blower door test done to it. It's going to be blower door tested. That is part of the certification requirements. That's reported, that's fed back into your energy model and reported out for certification. So the airtightness of the windows is only one component of that overall airtightness result, but of course it is an extremely important element. If you've got leaky windows, that's going to show up in the end when you actually have to, show off how your building is really performing versus some theoretical energy model. In terms of the actual process of certification, depends a bit on where the manufacturer is at. Most of the time, in my experience, manufacturers have an existing design that is either close to or not, or is not meeting the passive house requirements. But there will be some design that starts us off, and we would take the existing design, put it into our energy modeling software, get a sense of where it's coming out on these different metrics that we've talked about, and take a look if it's meeting the criteria. Again, in my experience, it usually isn't the first time. There's usually a bit of iteration that's required. So we need to circle back to the bottom there, provide the feedback, revise the design, and then model and evaluate the new design. But once all the modeling is complete and the documentation is complete, that gets submitted to the Passive House Institute in Germany, and they sign off and provide the component certification and certificate, as well as the seal that you can see an example of at the bottom right there. I've got a few pictures just showing an example of what the certificate looks like. So we showed a zoom in of a different example there earlier, but the comfort, hygiene, airtightness requirements, as well as some info on the model and some examples of the performance of the window frame with a few different types of glazing. That's on the right-hand side with the blue, the dark blue and light blue banded columns there. Because we know, different glazing is specified for different projects. The certification is necessarily done with a standard glazing to sort of remove that as an element, because what we're testing is the window frame itself. But we know that in reality, of course, different solar heat gain coefficient glazings, different types of glazings are going to be used. So we want to get a sense of where does this window come out, with these different combinations. And those are listed there for informative purposes. In addition to that, now I know this is going to be too small to read, but on the left, that's a summary of every one of the modeled junctions with the dimensions of the frame, the performance from a U value perspective, the minimum surface temperature, the comfort criterion, and the hygiene criterion listed, as well as on the right side, you can see some of those install models. So that would be an example of a frame that's certified with 3. Some would certify with more. But what this gives us is a set of standard psi values, if people are familiar with that terminology from thermal bridging analysis. So that's an assessment of how much extra energy are we losing through that install. That's included in the certificate as well. And project teams will have access to that data right from the get-go to start throwing that in their energy model, so they can see what's the impact of using this window versus that window right away. Just a little bit of further info about certification itself. We are seeing an increasing number of projects, both in Eastern Canada and across Canada as a whole. Certainly, I'm based in Ontario. I'm seeing this rapidly picking up traction, is projects that are specifically requiring Passive House certification or performance proved to Passive House methodologies as part of their request for proposal. If you want to submit, if you want to bid on this project, you need to be able to demonstrate your performance as per, this methodology that we've sort of been talking about today. In addition, I kind of hinted at this with the certificate, but a project team that is looking to design a Passive House, the quicker they can get their model up and running, the quicker they can get a sense of whether a product is going to work or not. I showed the 5 principles of Passive House earlier on. It's a balance, right? We're not there. There's no specification that says you must do this, you must do this, you must do this. It's not like code minimums, you need this R value or whatever. It's the building needs to meet this outcome of those, the really reduced space heating that we showed before. If you want to do a little bit extra on your walls and then give a little bit on your windows or vice versa, you do have that flexibility. But the only way you can start making those decisions is if you have the energy model up and running and you can start comparing your different options. So any component that is certified is added to the database, the project database. You can see product database. You can see a few pictures of it there at the bottom, and a project team can go right onto that database, pull out the certificate, they've got the data, and they can run with it. And they can say, yes, we know that this will work. We need to talk to these guys, or no, we know this won't work. We need to move on. And, in terms of, sort of leading on from that discussion of benefits of certification, something that Passive House Canada is going to be offering in the new year is a brand new developed modeling course that is specifically manufacturer and really manufacturer number 1 and consultant number 2 focused, but it's specifically about modeling Windows 2 Passive House methodology. There are some people across Canada that are capable of doing this work right now, not a whole lot. And what we want to see is more people that are able to undertake this analysis. When we receive submissions from manufacturers, usually we have to do the modeling ourselves, and it adds more time to the process. If we want to increase the uptake or increase the speed with which new components become available, this was one of the needs that we saw. So we're offering training to anyone that is interested, but again, specifically focused on manufacturers to go through in much more detail. We've only got half an hour here today, but this is going to be a 4 half-day course going through all of the details of specifically boundary conditions of modeling approaches, conventions and requirements, details of all the standards, the use of the modeling software to enable manufacturers and consultants to do this analysis beforehand, do it upfront, do it early, and sort of start getting a sense of where their performance is at to, short circuit that journey, let's say, to make it a lot quicker than it has been. And just some additional resources. So these might be a little bit small, but the Pacifist Institute, their criteria for Windows certification is 100% available for free online, pacifist.com. You can download that document on the left, and it'll give you all the details, even more details than what I was able to quickly go through here today. And on the right, Fenestration BC a few years ago put out a guide that is specifically about how to model these windows in Therm. That part is helpful, but really the more helpful part of the guide is it goes again through the detail of it goes step by step through the process of modeling a window to the Pacifist requirements. So by taking a look at that document, you will get a sense of, it will walk you through the sort of elements that I've gone over here, again, in very high level detail, in much more detail than we had time for. And that also is available for download free online. Okay, and that is all I have. Thank you very much.
Questions for Cameron?
Cameron, thank you for an excellent presentation. And you mentioned in your presentation between the Passive House Windows certified and the project certified. I am representing inline fiberglass. We have a certified Windows. You possibly were involved in it. And on the project itself, with our high efficiency window, after the test might be no efficiency at all because of the installation. Now, is there any approach to train the trade people to do the proper installation? Because we're facing this, like we don't have a crew which is a union crew. It requires, especially for the government project. And so is there any pressure or any program for the installers to go through the kind of the certification?
Yeah, so just to repeat the question, or to summarize the question, it was about is there training available for tradespeople, for people that are working on site, to make sure that even if we draw great detail for installation on the computer, we need to make sure it's carried out on site. That's a great point. Yes, absolutely. So Pacifist Canada, as well as some others across the country, offer tradesperson specific training for that particular reason. We know it's all well and good for us to sit on the computer and do what we want, but what happens on site is really what matters. And yes, for the last couple of years, that's something we have been offering. We're starting to offer it more regularly as there's more uptake. And sort of on the other side, what we're seeing is from project teams, as more projects come online and as more design teams actually get more experience with Passive House, they're understanding the importance of, for example, doing site mock-ups, right? Of taking a window and installing it and saying, let's put this together. Let's make sure that the sequencing makes sense. Let's make sure everyone is on the same page, that everyone on site understands how we want this done, or also reveal, any issues that might exist in the detail as drawn. So those are kind of two advancements in, let's say, the last 3 or 4 years that have picked up. So it's certainly not everybody is educated yet, but it is something we are trying to push forward on and offer additional training and guidance on, for sure. Yeah. Right. Exactly. Yeah. And you know what, my experience with those people that have been doing it for 20 years is, it's not about telling them they're wrong or anything like that. It really is just, hey, here's another way of doing it. And in my personal experience, they're usually receptive to it. It's here's what we're trying to do. Here's the outcome we're trying to achieve, right? And when you explain that to people, they get it, right? It does make sense. So That really is a big part of why we wanted to offer the. It does take some time, yes, it does, but you know, you have to do it, right? Yeah, it is time well spent, I think, because otherwise, you know, again, you can draw the prettiest detail you want, but if nobody knows how to build it, sort of, what was the point, right?
Any other questions? John?
From a window point of view, what's the distinction between passive house, R2000, and net zero?
Okay, interesting question. For net zero, I think it kind of depends on what sort of net zero you're talking about. You know, net zero can mean a lot of things. I guess at its most basic, it just means you're balancing your use and your generation, really. So, you know, I touched on it a little bit in the presentation, but we could take any building, we could take this building and make it net zero if we had enough room for solar panels, right? So for Passive House, we're really trying to focus on that piece that I showed up front of shrinking the demand, right? Shrinking the amount that we need. And then if we want to go to net zero, it's a lot easier to do it. We can do it with a much smaller generation system. So net zero is kind of its own, or there are multiple people that will tell you they have their own net zero standard, right? So like it's a bit hard to say. R2000 outside of my realm of expertise. Maybe somebody else in the audience can tell me what their requirements are, and we can put up my chart. But yeah.
Anybody else? So Passive House is a bit intimidating to a North American manufacturer. You know, there's so many programs that we're already trying to follow: net zero, R2000, Energy Star, NFRC modeling, and on and on and on. Do you have any information about the growth of the Passive House world? And is there a developing market for somebody to, you know, to get into Passive House certified products?
Yeah, that's a really interesting one. I wish I had more hard data, and I wish I had more things I was allowed to talk about here. In terms of growth, something we actually were talking about a little bit before the presentation was around supply. What we have seen in, the last decade roughly is 10 years ago, it was a lot of imported product. There's still a lot of imported product, but a lot of European frames that were being brought in and then put together here. That absolutely still happens, but we are certainly seeing a growth in local manufacturers, in Canadian manufacturers that are building and supplying product right here in Canada. Sort of anecdotally, the growth is, and one of the reasons that I'm here and giving this presentation and trying to make the pitch to window manufacturers is we know we need more supply than we have available right now. We have a lot of projects ongoing and a lot more upcoming. I wish I could be more specific, but perhaps that's for another presentation next year. Maybe I can say.
Okay. Anything else for Cameron? All right, Cam, thanks very much. We're going to have a couple of minute break, and then the Tech Services Committee meeting is in here, and it's members only. So unfortunately, if you're not a member, can't be in here. All right. Thanks very much.